Okay, good morning. Can you hear me? My name is Maciej Gawinecki, and today I would like to tell you about my contributions to this year on my second year of my PhD. My tutor is Professor Giacomo Cabri, and my co-tutor is Professor Maria Gansa from Polish Academy of Sciences. And I would like to tell you what I do in my research in reuse of public web services. So I work in software engineering, and in software engineering we are trying to help people to build applications in a short time, the applications which are reliable and for small amount of money. So one of the most realistic ways to produce such a software is to reuse existing components that other companies has already built. And as you can see, this is an application, and one of such components is a web service. And to build an application, we are looking for a web service that will calculate a distance for 2 USA zip codes. And this problem is quite big because there is a number of web services on the web. According to some reports, there is about 2,800 of big web services on the web, and there is no authority to categorize these web services. And usually the documentation provided by providers of web services is quite rudimentary. So what we want to do here is to provide a better description of what this web service does, of its interface, and then using this information match web service according to the user request, and then find web services from the bunch of web services on the web. So this was my goal, and what I proposed here is a method where the community categorizes web services according to documentation provided by web service provider. So here on the left you have guides which provides different tags for objects, which in this case are web services, and people usually provide the same tags to both annotate web services but also to recall, so find web services. So the same language is used for both purposes, but what is the difference with respect to traditional collaborative tagging is that tags are structured. So they are not flat because you describe both interface in sense of input and output of web service, and you describe also the behavior, the category of what web service does. Why do I do this? Because during the matching, it's important to find web services which either have similar interface or they do the same thing. Because you can have two web services which have the same interface, but they do different things, like web service which provides distance for 2 zip codes, but one provides a straight line distance, another one provides driving distance. Or you can have web services which have different interfaces, which is very common, but they do exactly the same thing or slightly similar thing. So they provide kind of geocoding, but one for zip codes and another one for geographical coordinates. So it's still geocoding. And matchmaking of web services is simply based on traditional information retrieval model when we use term frequency and inverted document frequency. And instead of frequency, what is important here is the number of people who provided a given tag for a web service. So it's kind of power of crowd. The more people provided a tag, then it is more relevant for description of web service. To evaluate this approach, I participated in a semantic service selection contest, which was associated with International Conference on Semantic Web in Washington, and the goal of the contest was to compare different approaches which use different formalities to describe the same web services. less or more complex, and to show which of this formalism and which of matchmakers based on this formalism provide a better effectiveness. So on the top left corner you can see a blue line is my matchmaker, which took the first place for effectiveness, and on the top left corner you can see also that the matchmaker responds in a very short time, which is quite important because when you search for a web service, it's quite complex decision, and usually it's not like question response and you get the end. It's like exploratory search, and you find web service, you know what's on the market, then you refine your query, and it's like with interaction with Google. So the contribution, the main contribution, is that this formalism is very simple, not complex, and at the same time provide a good effectiveness, which was quite ashaming for some formalisms which are much complex and use ontologies, but still provide a not so satisfying result. The drawback of this approach is that the community may be selective on which services to tag. So instead of having some experts to annotate your web service with ontologies, people in this case may select web services, for example, they like. So web services which are not popular may not be tagged at all, or maybe tagged with not enough number of tags. This is one problem I attacked. Another one was about integration of web service interfaces, which I did with DB Group, particularly with Serena Sorrentino, why? Because interfaces can be seen as a schema of structured or semi-structured data, and the problem is to find mapping between two different schemas. And what is the approach of DB Group is to find semantic annotations for elements in the schema, and then to show that two different elements that have different syntax have the same semantics. So what is done here, what you can see here, you have two different schemas, one with element called amount, which is associated with WordNet synset, and another one is QTY, which is probably abbreviation for quantity, which is a synonym, but we cannot check this unless we expand this solution. So if we expand this manually, usually this is done by generating dictionary manually for each pair of schemata. We can see there are synonyms, but generating such a dictionary is quite a huge effort for people, especially if you have big schemas. So what we wanted to do is to limit this effort that user spends on preparing such a dictionary, and we proposed a method for expanding abbreviations, and we started first from analysis of what are the schemas on the, what are abbreviations in different types of schemas. And we discovered there are 3 different types of abbreviations. First, there are ad hoc abbreviations, which are very also popular in source code when you generate an abbreviation just to save space, and this is usually not a standard abbreviation. So it's quite difficult to find such kind of abbreviations in the dictionary. And we found that expansions for these abbreviations can be found in the context and schema that is complementary to the abbreviation. There are also standard domain abbreviations like ISBN for books or VAT in financial domain, and you can find them in, for example, in online abbreviation dictionaries, and there are also some standard schema abbreviations. But once you get these different expansions for your abbreviations, you need to select the right one. And our technique is based on 2 heuristics to select the right expansion. One is based on the popularity of expansion in domains that are common for both schema and abbreviations. So if you have a schema about finance, financial domain, and one of the expansions comes from this domain, you will select probably this expansion. And also because you select expansions from different sources, we decided that some of these sources are more relevant because they reflect better the intention of schema designer. And the tests we made so far and published were done on two quite simple amalgam schemata, and the effectiveness of the approach is about 83%. So it means that for the 17% of elements in the schema, you still need to correct your abbreviation or your expansion. And you can see on the left you have different abbreviations. In columns you have different sources used. So you can see that these sources are really complementary for providing expansions of different types. And if you combine these different sources, you can have a very nice accuracy of your approach. Okay, so these are my publications. The first was recently accepted, and just the last, we are quite proud about that because it was selected, I think 6 among 31 papers accepted for the track of the conference were selected for DKA journal, and we are currently preparing expanded experiments to verify if we are really good. Okay, I'd like just to use the occasion and thank you very much for people who helped me during tagging web services, because without them I couldn't verify. The people in red are people from Italy. Okay, thank you very much.
I want to tell, to make a note, because it is an example of collaboration between two students of the PhD school, Maciej and Serena, and the result was real good. You know, the paper was selected for a well-ranked journal. And the other, it's an observation. Did you read the paper Collective Intelligence by Gruber?
Not yet.
You have to read it because it's just suggesting that there is a formalized intelligence which comes from structured sources and whatever, and there is this new collective intelligence coming from people, community, social networks, blogs, and so you are following the idea of Gruber, who was the founder of the ontology. So you have to read this paper. Okay.